Hi guys, so today again we will discuss some DSA problems in DP. So let's start. So yeah, let's find the problems first. Where okay, we are solving these problems and we have solved this. And now let's go for minimum coins. Whatever the problem is. So you are given an integer array of coins representing coins of different denominations, an integer amount representing a total amount of money, right? Return a fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. Okay. So let's take this example. Right. Okay. And okay. I think this is not visible, but let me change the color of this. Okay, so this is the color guys. Okay, alright, so this is a question for us. Alright, so we have these coins of one denomination, two denomination, five denomination. We have to make amount of 11 and output is 3, so minimum number of coins we have to find to make up that amount, right? So let's say what is the best way, right? We can take 5, then 5, then 1. This is the greedy approach, right? But let's say there was no 1 in this, right? For example. So how can we find that? 5, 5 and 2. This is no, right? Or let's take another example from here. Right? Okay. So, sometimes greedy approach may fail because let's say it was like let's say there was a coin of 4 here, right? So 1, 4, 5, right, and 6. These are the coins, let's say. And we have let's say 1, 5, 6 we have, right? I'm finding some example, guys. What could be the example for this? To show that greedy approach fails, right? Greedy fails here. Let's say there is no one here, right? 5 and 6, and target for us is 10. So we can't make with 6 and 4, can't make. But we have 5, right? So this is how greedy will not work. Like, let's say we have a target 10 and we have 5 denominator, 6 denominator. Why greedy will take 6, right? Then we have 4. Then we can't make with 5, right? It's exceeding it. So this is how greedy will not work here with that one. And so because there is no specification like one is present always or not, so we can't assume like one presents, right? So there's a problem. If one is there, so then greedy can work because it will always make up to that, right? Yeah. Okay, so without one we are finding, right? So guys, let's take again this example. This. Okay. Now we have that. So how can we solve this guy? 1 to 5 and 11, right? And we can say 2 and 5, 5, 6, 10, right? 1, 2 and 5. We have target 11. So how we can solve this? We can't solve this by greedy, right? We have to use DP. For DP we can find the recursion, right? We can always find recursion. Let's say 11. We choose 5 from here. 5. It's become 6. We don't choose 5. Become 9. Right? 9, and again we can choose 5 here. Remains 1. We don't choose 5 here. It's 4, 1. No. 4, 2, I think, right? 4, 2. We choose 2. We have to choose. We can't choose 5. We want to choose 2 because we have to choose 1, right? So this will return 1. This will return 3 from here, right? 3. This will return 3. And minimum we find, right? How many this will return? 4. We can choose again 2. We can now choose 4, we can choose 1 here, right? Because it's a sorted, so then 2. Then how many? 1, 2, right? So 1, 2. So it will return 1, 2, 3. Like it will return 1 or 2. Minimum of like this. Minimum this is 1. So minimum goes 1. Like this 2. Okay. So this is how this recursion will work. Alright. So let's code this recursion, guys. First try with recursion. We have amount, we have array. Is array sorted or not? I think sorted. And here let's sort this first, right? Sort. We have sorted, guys, this, and now what we can do? We have a function of recursion like integer function. It will take this coins array, right? Vector int I think coins, then it will take the amount we are targeting, right? And we are also what index on we are, right? Okay. And then we have index amount, alright. Is anything there? No. So this is the, so what is the base case? Let's forget base case. First check like if a or I is greater than, no, less than equal to the amount we are targeting, right? So what we can do, either we take it or we don't take it, right? Okay. So we have this okay, so if we take that, right, then what we have, coins amount minus I, right, comma I minus 1, because we are decreasing, right, now. Okay, one base case will be if I is less than 0, return 0, right? Okay, else so we are taking here, right? Okay, so 1 plus, okay, and take we are, so and take is equal to 0, we are taking that, so take is equal to this, right? Taking, if we are not taking or we can't take, right, and not take, we have equal to for coins, comma amount I minus 1, take and not, we have, okay, and what we will return minimum of take, comma not take, right? Okay, alright. And when we will return 1, in that case we will return if amount becomes 0, right? If amount 0, return 1, right, in that case. Okay, so these are the cases. I think we are going good from here. We can drag it down, but before that, if amount let's tackle that later, but if amount is like, we don't have to make any amount, right? 0, return 1, I think, I don't know. amount is 0, so always return 0. Okay, 0. Alright. When is the case like amount is we can't make the amount, right? We have to return 1 in that case. So how we know that we were not able to make the amount? So is there any trick we have to? I think we are doing something wrong because let's say we are not able to make that, right? So okay, minus 1 is this. No. Do we need to do minus 1 here? I don't know, because let's take this function from here. Let's try run here. We have like 1, 2 and 5, right? So I is here right now, so amount is 11, right? It goes 11 goes let's say here. If amount is 0, no, I want to take. Okay, amount is yes, so take is 1 plus f of coins is there, and amount becomes how much? 6, right? 1 plus 6, right? And I minus 1 is there. So we can take more times, right? So why we are decreasing that? So we should not decrease this, right? Okay. So I think one mistake is like we should not decrease it. We can take that like this. Okay. And we have 6 here. One more thing was not take. So not take is we have on 2. We are on 2. So it's only 11, right? Okay. Then we go in this case in the 6 one. We again can take 5, right? So 1 plus 1 will left, right? And when it is 1, we cannot take 5, we go for 2. We cannot take 2, we go for 1, we can take 1, right? So when we take 1, so it goes 1 plus 0. It will return 0 from here, right? So it will return 1 when amount of 0. So 1 plus 1 is 2, 2 plus 3, 3 plus 1 is 4. So 4 points, which is wrong answer, right? So what should be the answer? Okay. So what we should do? Amount to 0, we have to return 0 from here. But one more way could be like this. When amount is 11, take and not take. We have to plus this. No, not like this. We will return 0, like let's say it will return 0, then 1 plus 3, right? But because let's say we don't have this 1, we had this 3 and it was 12. No, not like this. I'm saying like where we can't make that. Let's say it was like this 5, 5, 3 and it is 11. No, 3, 4. Let's make it 4, like, okay. 5, 5. 5, 5. It becomes 1. So we have 4 right now. We can't make 4. Okay. So it returns minus 1 from here, right? But this will return minus 1, this will return minus 1, right? So this minus 1 will not work here, right? Because we are adding 1 there. Should we take a flag? Like flag is like it will tell that we were able to make it or not, right? Yeah, we can take this flag. So let's take the flag. Bool flag is equal to false, right? We can take this flag like bool flag. Okay. We can take it as a reference also. If amount ever becomes 0, right? So flag will be true. And if flag is true, right? If flag, so and answer is f of coins. We are giving the amount, we are giving the n minus 1, comma flag, if flag, right, we have to return answer. Once return minus 2, right? And what is n? N is coins of size, right? Okay, so return 0, flag is 2, not return 1 is 1, return 0 only. Okay, so if I is very less, so we have, because we are moving minimum, so we should return very big number, right? 189. Let's return this. We'll find 1. Oh, there is no error, guys. Coins. We have coins everywhere. So if I okay. Alright. Flag. Wrong answer is 7. Output is 2, okay. Expected output was 3. Alright. Right, so we go for this. I don't know. Again, output is 2, expected was 3, okay. What was okay, so 1 is given us some. Okay, so these cases are handling well, but this case is not handling. Amount is right. Okay. Is this about I minus 1 thing? So let's check like what is our below this. Check. I am not asking for the solution. Into 3 tests take equal 0 rate. Okay. Look at how should I take the measurement is where I want to do it. Coins the statement is kept. Take the number 0 and not take measurement and then this translate overtaking also will be right like this. We said regulation like required to do level difference. The burden of imagination and image one of the So it's really 39 passing, but it's not passing all. So what you can do, we have to apply the memorization. To apply the memorization, guys, what is changing, right? One is amount is changing. Amount is variable and coin is variable, right? Coin is variable like index. So we have this like 1, 2 and 5 here. We have amount of 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So can we make 0 with 1? No, 0. Can we make 1 with 1? Yes, with 1 step. Can we make 2 with 1? I think 2 steps, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, like this. Can I make this 0? No. Can I make this 7? No. Make this 2. Yeah. Only with 1, right? Which is minimum. Okay, so can I make this 3? So with 2, 1 and 2, right? So yeah, I think because 3 minus 2 is 1, and can we make this by 1? 1, yes, 1 is this, 1 is this, is 2, right? Then can we make this 4? 2 minus 2, like this. 1 is like 4 minus 2, like this, and minus this, 0. So yeah, it will make like 1, 2, 1. 1 plus 1 is 2, right? Then 5. Can I make this 5? Yes, I think. Like this and like this. Okay. I think I found the memorization in here. So let's go for this coding. denomination we have a total, we will take a total dp for this, like vector of vector integer, right? dp there how many n, right? n comma, okay, so because we are tracing I minus 1 also, right? But we can do that also. Okay, so we have to take n plus 1 vector of integer amount plus 1. Okay, so how we can initialize it? I think 0, right? Okay, 0 we can divide like this, okay. And if amount is 0, right? So amount is 0, then how many ways we can do this? So 4 and no. Okay. Okay, let's just take this dp from here, right, and pass it here. dp just dp like this, pass it by reference. Okay, let's go for minus 1, right, like this. So dp of I comma minus 1, no, amount now is equal to minus 1, return dp of I comma amount, right? And then we can dp of I comma amount, we can do like this, right? And where we return this, we can return dp of n comma amount, right? Okay, so I think also we don't need this also, I think. Okay, we can do this also. Can we find this like okay, we have to go dp like this, we have to cause dp here also. Okay, n plus 1, what is n plus 1, guys? Okay, n is not defined here. Alright, let's take this in there. Case 3, okay. because uh, why it's giving wrong answer, guys? Because uh, let me check what is the error, guys, here. Also, it's very difficult sometimes. That's the problem. Navigation never called the function looks at the bottom of the code. Non-zero answer is you just built a multi-million-dollar supercomputer like DP table and wrote a brilliant AI solve for now the power button immediately if empty what I did. Okay, let me. I think these are small bugs here. Okay, so the thing is, guys, I have to call the functions right first. So okay, answer is equal to this. F of coins, comma. What are we? The next thing we are taking the amount, right? Then we have this. N minus 1 is index, and we have then I think flag, then we have GP. Answer like this. And okay, let's check now. Auto buffer, okay. I think it's N minus 1 here. Right. Okay. Let's try to submit it. It's accepted, guys. Okay, as you can see. So I think was like that, and next thing what we can do, we can run a tabulation also in that. So let's go for tabulation from now. We have to initialize it like we have to take this also. Okay. For I equal to 0, I is less than what? I think we have amount is 0, right? I is less than equal to n plus dp of I comma 0 amount equal to always 0 answer, right? And next thing is what? Amount is 0 to then 0. Also one more thing was if amount is 0, all will be 0, right? And this line, let's say we have this okay. If we have this amount but the value is 0, right? Value is 0, then how many base? Then this also will be 0, right? The value is 0. Okay. So okay, let me see. or I can do this 0, or should it be maximum, right? Maximum. Let's say like we have this 0, 1, 3, 5, and we have only 2 denominator and 5 denominator. So can we make this so it should be 0, 1, and 0, I think, because this plus it's not equal to 0, right? So it should be not equal to 0. So we can't make this. Three minus 2 is 1, 0 it is. So it is 0, right? Else I 1 E9. Okay, this is all 0. This is maximum 1 E9. 1 E9. 0, 1 plus 0, no, not equal to 1 in 9. Okay, then we can look into it. So I minus 1 is what? I should be from 100. I is equal to 0 is full. Alright, so what I can do, guys, is in the amount for lambda is equal to 0, I realize then amount is equal to amount I plus, right? So we can take it like j also this. Let's say this is j, this is j, this is j, right? Now if we are taking like this if if you have 0, j not equal to minus 1, right? J minus comes A. if j greater than or equal to, right, coins I, or we can say coins j, right? Only then we have to run this, right? Then if it is like this, not equal to, and the jy equals I, equals j is not equal to like this, then what can we do? dp of j 0 comma j is equal to 1 plus dp of 0 comma j minus coins j. Correct. This is the initialization here, and now we can run this. For n is equal to 1 I less than equal to less than n plus this like this, and we have this we have this 4 into since j is equal to 1, j is less than equal to 1, j plus, right? Now what we can do? Okay, so we have to initialize like big numbers because like this. So what we can do, we can like dp of I comma j is equal to dp of minimum of, we are taking like a dp of minus 1 comma j, right, comma when we are taking the dp of I minus 1 comma j minus coins I, right, plus 1. Okay. Only if j is greater than or equal to coins I, right? I comma j is like okay. So this is what I was doing here. Let's say like this 1, 2 and 5, right? We have 1, 2 and 5, and we have what, wait a minute, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is all 0, right? 1 is 1, 2, 3, 5, 6, 7, 8, 9, 11. This is inside like one thing like this. 2, no, oh, this is maximum here. This is maximum, no, not maximum, because I minus 1, right? Maximum comma 1, this is 1 here, right? Okay, so and do 3 like this, minus 3, this is 2 here, 4 is like okay. Alright, so I minus 1 comma 4 minus 2, which is 0 comma 2, which is 2 there, right? So 2 plus 1 is 3, and other thing is I comma j minus points minus 1. This is max, right? So we have to consider this also, right? So also j minus points I, and this is only I plus okay. Wait a minute, I will go through this. And this is 2 like this. This will come out 2 here. 5 I minus 3, which is 3. Five minus 2. Three, can we make 3 here? With 2 can we make 2 with 3? Okay. 3. 3, okay. 5 we can make here. 3.6, 4, 2, 3, we can make 3 also. 7, 5, 3, 4, I think. 4, 6, 3 plus 4, I think, yeah. 9, 5 coins. Okay. 5 coins. 11, 6 coins. Now we have 5. It's max 5. Okay, 5. So I minus 1 comma j, 0 plus 1, 1, 0 plus 1, okay, 1. Then 6 is what? 1. No, it should be the 1, right? Yeah. It should be 1 like this. So one here, right? Two here. If it is not like this, then we can, if it is not like this condition, okay, else dp of I comma j is equal to dp of I minus 1 comma g, right? Okay, then at the end what we can do, we can return dp of and minus 1 comma float. Okay, I think that's good. What do you think? G minus 0.0. Yeah, I think it's correct. No, yeah. Okay, so G value. Runtime why? What's happening? I think you can say so we are making some mistake because I'm not today we are doing this. Something like this. What's the problem? Let me see. I can't identify that. I am not that of an expert here. Right? Okay, what was the problem in our case, guys? Let's see. Bug 1 is to boundless 0 coins J. First row, okay. Please look variable amount of it. It must be coin 0. Yeah, it's like I changed it, okay. I changed it, guys. Okay. Okay. Then what is the second bug here? Not take corruption. Imagine you have a cashier trying to mutation, you are trading. So when I quoted 1 million coins, so what's the total value? So target amount J must run completely. Okay. Okay, so I think I found these cases here. What do you see? This okay, this 0 is there, okay. Well, now take so okay, like this not take is equal to I minus 1 comma j. We are taking from take is like, so it's unbounded knapsack, so we are not taking like I minus 1, we are taking I. Okay. Take common not take 1 plus like this. Okay, now I understand what he is saying. Like this, he is saying enter take equal to 1 you cannot take is like a db of I minus 1 comma j. Directly we can give this, right? And it's like take is equal to okay I right. Okay. However, dp of I comma into meaning of take comma left and right. Then if dp of m as 1 comma amount equal to 1 in 1 second minus 1, right? Whatever. Wow. Now it should work. Okay, so runtime is good. I think it's good. I think. Let's move to next question. We have done this. What? Which one? Points, right? Now we have this target sum question. We can do this also.
Și am zis că, nu știu, dar
Okay guys, let's again do this. You want to build an expression out of this is a question. You are given an integer of nums and integer target. You want to build an expression out of plus, okay, nums, then concatenate all the integers. For example, if num is 2 minus 1, add before 2 and minus, okay. Return the number of different expressions that can build, which I will use to target. Okay, so we have to find this. Okay, alright. So we have to find the number of ways, right? So if there is an array, right? How many ways we can find the target? Okay, let's discuss this. Okay. We have this array of 1, 1, 1, 1, 1. So either we can, let's say we are in this index. Either we add this, or subtract this. Right? If we add this, right? So this becomes 2. This becomes 4, right? Then again we add. Okay, then we add comes 1. This becomes 3, right? Add, subtract, plus, minus, right? Next we are here, then we are here, like this. So we have to find if target is equal to 0 when we are at last, right? Last index. Then we return 1. Okay. Else we will return 0. Okay. So let's do this. We will have a function here. Have a function, right? Right. Okay. Yes, once we have integer I, we have integer target. Okay. Alright. Also we have integer a. Okay. 1 is plus, 1 is minus, right? So into plus is like we are plusing it like okay, so nums I plus 1 and target minus nums I, right? And into minus is equal to nums plus 1 target plus nums I. Okay, so this is the take plus normative case, and let's know this. Okay, so what is the base case? If I is equal to n minus 1 and not n minus 1, like n, and target is equal to 0, right? Yeah, we were able to achieve that. Okay, then we will return 1, right? Return plus comma minus. Okay, else if I is equal to n, return 0, and okay, what we have to pass to it, we have to return f of nums I is 0 here, right? Target and nums size, right? I think it's good solution. No, okay, we can't pass like this. Okay, alright. No, alright. Okay, both cases passing here. I think it will give us TLE because oh, it's accepted, guys. But it's very slow, I think. 142 case passes, all of them. Runtime memory, we are beating all of them because we are not using any memory. And I and target is changing here, guys. So how can we convert it in DP memorization? So we can convert it in memorization like because some can go to in minus also, right? So we have to take the offset also in this case. Alright. So let me check what's happening here. Alright guys, how can I do that? Do you have any idea? Okay, so memoization I have to change it to memoization because two variables are changing like target and I, right? So okay, so let me find that 2D array, but let me find the description first, right? The num sum, so sum cannot go to one greater than 1000, right? A target can go to like minus 1000 to plus 1000, right? So guys, let's say num is sum is 1000, right? And target was also 1000. So one this and this is 2000, right? Okay. So this maximum it can go to 2000. Okay. So let me find this after this line. Okay, Control C here. Alright. Like this here. So what I'm saying, length, let's forget the num's length, right? This is 20. Why? We don't care about it. Every value can go, max go to 1000, right? Num's length. And num, this is saying like sum of this, like if we sum all of the num value, it cannot go to greater than 1000 also. And target can go to minus 1000 to 100. Okay. So if target is 1000, and if we are adding this, like we subtract from target, so we can subtract like till 1000, it will go to 2000, right? Minus, and we are target is plus minusing, then subtracting, and also it can go to we are getting plus in this. My target is negative, plus plus in this, plus 1. Can we achieve the target? No. So we have to manage this, no? 1000. We subtract. Okay. So it will be minus, if we subtract, minus 2000 it can go, right? Minus 2000. Okay. To, this is 100, right? 1100. So minus 2000 to like plus 2000, let's see. Okay, it's going to total is 4000. So offset is like plus 2000 here. Okay, plus 2000 is offset. Alright, and amount there is like 4000 here. Okay. We have this ADK, if you want, vector of integer here, DP of nums dot size, right, comma vector of int, I think 4000 5 comma -1. Okay, then okay, we can uninitialize with 0 also, right? So we are passing this dp, right, and we are taking this dp as as reference. We can pass this here dp, right? We can pass here also like dp like this, and dp of I comma amount plus offset, right? Do this int of so it is equal to 2000 values, right? Okay. -1 and dp of I comma target plus set is not equal to this one, then return dp of comma target plus offset, right? If like this, so like that, okay. Then after that, okay, return dp of, so we have to I, which is not I, which is nums dot size -1 and which is n, right? Comma I think 0, right? I don't know. Target plus 2000. What do you say? What is comparison amount? What is amount? What is target? There is no amount. Right? Okay. Wrong answers all over. 2 is okay. Output is 0. Okay. What is my problem in this? Can you tell me, bro? Okay. Only evidence is outstanding of successful played also stack subsequently played together flawlessly met. Okay, however, a code has fallen into a ghost trap when missing a critical metal condition. Okay. So Bhagwan in your ghost trap is like at the bottom of the code, you triggered a master recursive function which is 0 dp. Then you ignore what it returns. Try to return directly from the matrix. Return dp real energy. You are an content when just higher and equal to the started digital. Tell me how many ways this argument. Whenever you throw it and press breaker and the filling cabinet and the sub file for the very large data. The top down dB in the zero transition logic, the final variable function which called request dp0 is my hold the sub answer and first number just return. So okay, out of bounds case. The problem constraint state that the sum of elements will not exceed. Therefore, the absolute minimum target to be reaches 1000. Whatever it could passes with this. Code executes. Okay, like offset 2000 to return 1. Okay. Okay, this is correct here. This is also correct. Right. This is also correct. Where is the other one? The target is return 0. Okay. Right. Okay, just return function I think I have missed. Like this I was not. Alright. Like this. No return statement will not be working. Then I can check here. Right. Yeah, it's working. It's accepted and now it reaches 43%. We will not go for the tabulation method in this because I don't think so. We should go for this. You want you can go. I don't have much time. I am going for the lunch. Then I will try to solve this question. Point change to right. Okay. Then we will do these 3 questions after. And then TP on stack, TP on stack, TP on long version something. We will do all of them, right? All of these questions in 1 or 2 days. Alright, so let's go back. Thank you so much.